So hello students, in this video I'm going to discuss with you the past paper questions from the AS level Cambridge board examination, and the topic is enthalpy changes. This is the topic which many students find difficult and they often get confused. So I have decided to explain this topic from the very scratch and going into the minute details of the solution so that you are able to comprehend the topic very well. So let's start. I have taken a question that you can see is from the October 2018 paper, and the variant is 229701 is the code. So let's see what was the question and how it had to be attempted. So see, the question says trihalomethanes are organic molecules in which three of the hydrogen atoms of methane are replaced by halogen atoms, for example CHF3. The equation shows a reaction to produce CHF3. So this is the reaction: CHI3 solid plus 3AgF solid gives CHF3 gas plus 3AgI solid. So the physical states also have been mentioned, even though the physical states don't make a difference as far as the method of solving this question is concerned. So, and data is also given for the different compounds, CHI3 solid, and various reactants and products which are mentioned in this question. The enthalpy change of formation for these compounds has been mentioned over here. Now you must know what do we actually mean by the enthalpy change of formation. So I have explained this concept here, that when the elements combine together to form any of the molecules, like for example carbon and hydrogen react to form methane, or carbon and hydrogen react to form some other compound, so whatever enthalpy change takes place is known as the enthalpy change of formation. For example, if we have to form water, right? So if we have to form, for example, water, right, then what should we write as the equation? We should write H2 gas plus half O2 gas gives H2O liquid. So this equation will be known as the equation for the formation, enthalpy change for the formation of water. In other words, we have to start from the elements. The elements in water are hydrogen and oxygen. Why do we write half O2? Because oxygen is diatomic and there is only one oxygen needed here. So we'll make it half H2O so that 1 mole of water is formed. So when the elements combine, then that is known as the enthalpy change of formation for that substance. So these values have been already given in the data, and now we have to understand that how do we apply that data to find out the, and how do we solve that question. So let's see, how do we solve that question. Okay, so if you now consider the Hess's law, then you see that when you go from the reactants to the products this way, from the reactants to the products, whatever enthalpy change takes place, that is known as the enthalpy change of the reaction. So you have to find the enthalpy change of the reaction. And when you go from the elements to the reactants, it is known as delta H1, which is the enthalpy of formation of reactants, and this represents the enthalpy of the change of formation of products. So by Hess law, see the two arrows. See, if you start from delta H1 and then go to delta HR like this and then like this, it is the same as going from here to here, which means that delta H2 is equal to delta H1 plus delta HR. So we have to find out delta HR. So you can see that delta HR is equal to delta H2 minus delta H1. So delta H2 refers to the products and delta H1 refers to the reactants. So we have to subtract the reactants from the products minus reactants. So here these are the products and these are the reactants. So products minus reactants. So for CHF3, what is the value? Minus 69, minus 692.9, which you can see here. And then you have to add this. So 3 times of AGI. So AGI is minus 61.8. So 3 times of that you will add. So this will all represent your products. Then the reactant CHI3. Now the CHI3, as you can see, what is the value for the CHI3? See this. For CHI3, what is the value? Let me go back. I think by mistake I came forward. So let's go back and see. Yes, see this. So for CHI3, the value is minus 182.9. So we do that over here. See, minus 182.1 and then 3 times of AGF. So AGF is minus 204.6. So 3 times of minus 204.6. So this is all of your products and this is all of your reactants. So products minus reactants, as I already told you, the products minus the reactants, and when you solve this you get the answer minus 82.4 kilojoules per mole. So that's the answer to this question. So I think you very well understood how to do that. So the method that we adopt is that we have to actually go find out the total enthalpy change of the products, right, and then subtract the enthalpy change of the reactants, and then we are able to solve that question. So I think you understood this very well. Okay, so this was the answer, 3 marks, and for all the steps. Okay, so let's go to the next question, and the next question is very similar, and I have taken it from the winter 2018 paper, and it is the variant 21 and the code is 9701. So let's look at this. So once again, a reaction has been given to you and you have to find out the enthalpy change of the reaction in the same way. That means when this reaction takes place, what is the enthalpy change? And once again, the enthalpy change of formation of the various reactants and the products have been given. So this question is very similar to the one that you did here, that you have to do the total for the products and then subtract from the products the reactants, right? The products minus the reactants, that you can very well understand from the enthalpy cycle. So let's do that. That's now very easy. We just have to see what are the values, right? So let's see this. So these are the products. So CHClF2, where is that? It is here, minus 482.2. So you see this X will be 1 because see there is only 1 mole. Then you have to add the other one, 2 HCl. HCl is minus 92.3. So this will be 2 times of minus 92.3. Then these are all the products, obviously. These are all your products, correct? Here this value is 1. Yeah, value is 1 and this is obviously 2. And then you have to take all the values for the reactants. So for the reactants you have CHCl3, which is minus 103.2, which you see over here. Obviously this is 1, and then 2 HF, so HF is minus 92.3, right? So HF is here minus 273.3, and this is twice. So just put the values and solve it, and you get the answer as minus 17.0 kilojoules per mole. So I think you understood this. This was pretty easy, and this was the question from the winter 2018 paper variant 21. Okay, now we are going to understand how do we solve the question which is based on bond energy. So the method for bond energy is a little bit different. So I'm going to explain you that. Now see, this question has been taken from the winter 2017 paper 21. Of course, the code is 9701. This is based on the bond energy. The bond energy refers to the energy which is required to break a particular bond, and it is in per mole units. So N2 gas plus 3H2 gas in an equilibrium reaction gives you 2NH3. The delta H for this reaction, that means when this reaction takes place, the enthalpy change for this reaction is minus 92. That is, it's an exothermic reaction, right? And we have to use the data to calculate the value of the NH bond energy. Now let us try to understand this. So I have taken this enthalpy cycle from your textbook. So see the same reaction, N2 plus 3H2 gives you 2NH3. So N2, as you may be aware, has a triple bond between the two nitrogen atoms, whereas the hydrogen only has a single bond, but there are 3 hydrogen molecules. So we've taken 3 here, and then obviously NH3 is like this, and there are 2 NH3. So this very well explains you with the proper structures, displayed structures. So because you have to understand which bonds are being broken, which bonds are being formed, so we have to write down so that we can understand that. So see, you have to understand these are the bond energy values. That means to break the nitrogen-nitrogen triple bond, we require 945 kilojoules per mole of energy. Similarly for the others, it's given. Now look at this enthalpy cycle. See, this direction is the enthalpy of reaction. This direction is the enthalpy of reaction. And it is equal to this plus this. See, this plus this. So this is like you break the bonds, because the reactants, you must break the bonds in the reactants. So you break this bond and then you break 3 of these bonds, then you get this. That means now there are no more bonds, all the bonds have been broken. Then you combine them and make the bonds, right? So now they obviously you can say that delta HR is equal to delta H1 plus delta H2. See this, delta H1 plus delta H2. So delta H1 now is the enthalpy change for the bonds broken, and this is the enthalpy change for the bonds formed. But whenever the bonds are formed, it's an exothermic reaction, and when the bonds are broken, it's an endothermic reaction. So that's the key. When the bonds are formed, it's an exothermic reaction. So finally what happens is that the formula that you get for finding out the enthalpy change of the reaction, you see very carefully that first we take the bonds broken. See, first we take the bonds broken in the reactants. So first you have to take the reactants, and then because plus minus is minus, then you have to subtract the energy required for breaking the bonds in the product. So it becomes of this form, reactants minus products. Whereas when we were doing the previous questions, you see, when we have to find the delta H of the reaction, we had done the enthalpy of formation of products minus the enthalpy of formation of the reactant. This is what we had done, products minus reactants. But here, as you can see, we have to do reactants minus products, as you can understand from this. So that's the very important thing that you had to understand. Now once you understand this, then you can definitely do this question. Now see this N2. So for these values, see the value for N2 is 944. So you will break this bond. So 944 plus 3 times of 436, and then you will subtract, right? Subtract for the product. So product is 2NH3, but 2NH3 you can say has got 6 NH bonds. See this, 1 2 3 times 2, 6 NH bonds. So now you will subtract the reactants minus the products. So this is the product, and 6 NH bonds are formed in the products. So the reactants minus the products, and this value we don't know, but we know what we get after the subtraction. That is your minus 92. Rest of it becomes easy, because this 6 NH will be equal to this, and then you will just take care of this value. But it gives you the values for the 6 of the bonds, right? 6, but you have to find out only one NH bond. So that means you'll have to divide it by 6, and then you will get the bond energy for the NH bond, right? So that's the way it is to be done, and I think you understood this. So I just showed you 3 different types of questions which are asked from enthalpy changes from the previous year's papers. Of course, there are many more different type, but you got a very good view and understanding of what is meant by the enthalpy cycle and how do we use the information given to solve the questions. Hope you understood. If you like, please comment and share the video with your friends and subscribe to the channel. Thanks a lot for watching.